If you recall, we are in the phase where we want to cover more or less the syntax, rules, theory side of things. So again, this lecture will be a continuation of this. Hopefully, if we manage today to finish this part, on Friday we'll have more applications, well, kind of hands-on programming together to apply these concepts. But let's see how far we can go. So yesterday we discussed variables, we discussed data types. We mentioned why really we need types, what are the three main elements of having a data type. And then we went into control statements, starting by if, right? And then if else and, well, nested ifs, etc. So today we are going to cover loops. Similar to if statement yesterday, this is not the first time we see loops in this course, right? We have used this, in fact, multiple times in our examples, but maybe not covering much the details of different loops, what is the syntax, and what are the rules, right? We have seen it, but a couple of times, maybe 3 times. We know the basic syntax, we know how it works, but not in detail. And again, that's the purpose of this stage. There are 3 main types of loops in most programming languages, in fact. There is the for loop, while, and do while. One very important thing to know is that all these 3 are functionally equivalent, right? They have exactly the same functionality, which means any program in the world that you really have loops in that use for loop, you can exactly have the same functionality of the program, well, represented by while loop, right? So they can replace each other. And this is something that is a little bit kind of not known by many beginning programmers. They think that if you use a for loop, that's it, and then maybe while loop can be used in something else. From a functionality perspective, they are completely equivalent, right? But then, why do we have both or 3 types if they are completely the same thing? Why we just don't have for loops, for example? And we also mentioned this before. Although they are functionally equivalent, some use cases makes more sense. It's more, I would say, intuitive or user-friendly or programmer-friendly to think about this control block in for loops versus while loops. And we gave the example of having iterations over a fixed number of iterations, like fixed count. For example, you want to read an array of 20 elements or reverse it, so you know your iteration bound. In this case, for loop is the more intuitive case, both for you as a programmer and also both for the user and the reader of your code. On the other hand, if you have multiple nested conditions and you don't know really for how many times this condition will be satisfied, then maybe while is the right way to go, right? What about while and do while? This is also what we'll discuss today in a little bit more detail. Good? The actual for loop we have seen before is that it consists of really, well, the header of the loop consists of 3 main statements. There is an expression, a condition, another expression. The first expression is your initialization expression, right? If you think of the simplest format for loop, you can say for I equals 0. And then the condition is, well, this is your termination condition, whether you should continue executing this loop or you raise stop here. And this is what is being checked in every iteration. And then finally, this is your step or your progress expression. So why this is necessary? Because if you really don't have a way to terminate your loop, this will be an infinite loop. And many of the problems I see also in labs in the past couple of years is that some of you unintentionally write infinite loops. And then the program keeps running, not showing them anything. Well, in fact, it's being executed, but it's stuck in a loop. And this usually happens especially in lab 4, because the condition in some of the questions is not very, very clear. So you have to make sure that whatever loop you are writing, whether it's for or while or anything else, you have a way to terminate, right? And here comes your expression. So, or basically you have a way, in other words, people usually say you have a way to progress. Like this is how software engineering books call it. Like you have to make progress in your loop, otherwise you'll be stuck in one point, right? You have to make a change, right? And this is your progression expression. Progress means, well, sometimes you increment, sometimes you decrement. So it doesn't really mean all the time you go upwards. We have seen the example that if I want to print the numbers in a reverse order, in my printing, I really start from the end of the loop and then I keep decrementing, right? This is also progression, right? So you are progressing in your execution, but in a different order. And then finally, what is the part of the code that you really want to repeat? That's the whole point of having the loop, is that you identify a part of the loop that you really want to execute equal to like specific numbers of iterations, like 100 times, 10 times, whatever it is, right? Or based on a certain condition. These are your statements here. By the way, in fact, if you don't have loops in your program, well, theoretically, you can also still write exactly the same program without loops at all, right? What can you do? You just really repeat those statements equal to this number of things. Maybe have if statements for checking conditions, right? But the problem is, well, this is not very productive. Think, for example, you want to repeat a certain code for a million times. Think, for example, about a graph database or something that processes a huge amount of data. Well, I cannot really write a program. Even if I keep writing or copying and pasting the code a million times, well, it might not really be enough, right? And this is the purpose of a loop. It just automates things for you. Good. So these are the statements that you really want to repeat if you satisfy the condition. Good. I know explaining these things is kind of looking into the basics, but understanding the spirit of a loop, regardless of the syntax, this just goes beyond C for any programming language. Okay? And if we look at it from the flowchart perspective and how to lay down these expressions and conditions and statements, you can have something like this. So here this circle represents whatever is before the for loop in your program, so we really don't care about it now. You start by having your initialization, which is your expression one, and then every time, so this feedback is really your loop. Every time you check your condition, if your condition is true, you execute the statements and then progress, which is doing this step forward or backward, it's up to you. And then come back and check the condition. You keep doing this until your condition evaluates to false, and hence you terminate your loop. Is there any question? Is that clear? Good. Okay, so I hope you bear with me as well a little bit, because one thing I have learned over these past 3-4 years is that I should make no assumption about what you guys have learned in the first year. So I know for some of you that already know these things, it might be a revision, it might be boring, but please bear with me just to make sure that everyone is on the same page, right? And those that really getting it in the first year Python course, then this is the time range to do it. Again, I'm assuming nobody knowledge, and we are reiterating all of this just to make sure everyone knows the concepts we are covering. Because the more we move forward in the course, the more advanced concepts we will have. And if you don't have the basics, well, it's done. You cannot really move forward in the course, right? To make sure you really cover these concepts. So this is a very simple example we have seen before, so I'm not going to spend time on it. But just how to map this into the loop itself is what might be interesting. So we said there is an initialization condition. Here is I equals 0. So there is some sort of sound that is weird. It's from the mic. The owl. I don't know. Do you guys hear any kind of feedback? Yeah, I don't know. Okay, so then you have your condition that you check, which is I is than 10. If it's false, which means I is equal to 10 or more, you just exit. If it's true, you achieve your statements. Here we only have one statement, and then you do your progression. If you really didn't do this progression correctly, or you don't have any progression expression, what's going to happen? Well, I will stick to its initial value. You will keep repeating this loop forever. This will always be satisfied, right? So this is the importance of having this progression expression. Good. Okay. Then assume, for example, I want to write a program that prints 20 stars, where I can just really simply have my condition for 20 iterations, and then I just print the star, right? Well, are these two equivalent? What do you think? Yes, from the functionality perspective, you will end up having exactly the same output, right? The reason is, in one of them, you started your iteration from 0, but you stop at 19. While the other one, you started iteration from 1, but you stop at 20. So they both will be counting 20. It's 0 to 19 or 1 to 20. It's the same thing. Then what about this one? But it will also give you exactly the same thing. I'm just really, for some reason, I'm starting counting down from 20 to 1. It will just show me exactly the same thing, and then I increment, right? So everything will really show you these two instances. Now, if I do something like this, and just to show you that it's not always really progression is an increment of 1, how many stars do you think I would end up having in my console? 4. And the reason is, why you would have 4 here? Yeah? Exactly. Thank you so much. So the point is, if I increment by 2, I have 0, and then 2, 4, 6, 8. In the iteration that I'm executing 8, I'm going to print, and then increment I, it will be 10, but this condition is not satisfied yet, because I has to be strictly less than 10. So I'm not going to print for the 10 case. So I'm printing 0, 2, 4, 8, this is only 4 times, right? Good? Again, this is just really how we visualize it. The only thing that has changed is really progression expression. Good. Then if I have a while, again, function is just exactly the same thing. It's just written in a different way. And the syntax is more aligned towards having conditions rather than number of iterations, right? So you have a loop that keeps executing as far as you have your condition as true, right? So you see here that we don't have initialization in general, and we don't have our progression. The reason is, the premise of a while loop is I keep always executing as far as my condition is true. In many cases, this condition, in fact, will depend on some sort also of a counter and the condition of the counter. In this case, you will have, well, an initialization and a progression, but it's not necessarily the case, right? And your progression condition is really, in fact, considered part of the statements inside the loop, as we see right now. If I want to basically print I in that case, and this is a for loop. So first of all, what output you end up having from the for loop? Yeah, a straightforward thing. I start from 1, I print 1, and then every time I increment, so I print in a new line 1, 2, 3, 4, right? Because I stop at 4. If I have an equivalent while loop, first of all, I would have my initialization expression before the loop itself, because again, while does not really have an initialization inside its header, and then my condition, which is this one, is the one that ends up in the condition of the loop. And then what about your progression expression, which is here incrementing? This will be inside the loop itself, right? So if you think about it, initialization became before the loop, progression expression became at the end of the loop, and the body is exactly the same one. Good. Okay, very basic. So if I want to write the general, if I want really to have, if I have a program that has a for loop and I want to transform it to have a while loop, similar to the example we just had, this is really the general case. You take the initialization expression before the loop, you put your condition inside the loop, and you put your increment condition at the end of the loop, right? And having this automated way, in fact, is something that's good because I can really write a Python script or a C code that really automates the transformation for myself, right? But this can be really automated, right? I can have a very simple exercise tell you write a program that reads another program file and checks for all the for loops and transform them into while loops, right? So you more or less do the function of a combine, for example, right? So it can be automated. Okay, so on the other hand, what if I want to do the other way around? I want to go through a program to change any while loop with a for loop. Well, I can still do exactly the same thing because I just told you that they are functionally equivalent. So in that case, what can I do? Well, I know that this is my while loop and this is how it's being represented in the flowchart. In that case, a while loop generally does not have initialization or progression. It all depends on the condition. Then in this case, well, I can write the for loop like this. There is no initialization at all. There is no progression. There is a condition, and then this is my statement. So this for loop is a valid syntax in C, and it's equivalent to the while loop. Is that good? I believe the AC is not working, right? Yeah. I feel, well, you better frustrated than frustrated, right? Let's see. Think of it as like a sauna for extra half an hour and see how. Okay, is there any questions so far? Yep. Yeah.
So I was working on one and I realized like when you write while in the condition, like let's say I is less than or equal to 30 and it's or sorry, I is greater than equal to 30 and I is less than or equal to 1,000, that doesn't work. Like you have to initialize I equals 30 at the start of the code.
Yeah.
Why is that?
Yeah, why that's the case? That's a good question. So one thing that we mentioned here and more or less discovers this part, if you have your condition based on a certain value of a counter or iterative variable, then, well, in fact, your termination condition depends on the value of this value. So if you don't initialize here, think, for example, of the following. Assume I want to write to this program, but I generally initialize I by any value. What is going to happen? Well, based on what we know, if I is not initialized, then in that case, it can take any garbage from the memory. Then when I compare my condition, I'm using I, so it's going to read whatever is there, and it might not work as expected. So this is why I said, if you want your while loop condition to be dependent on a variable, you must make sure that this variable holds the values you are expecting. If it was a counter, then you must initialize the counter and increment it inside the loop. For example, if you forgot this as well, so you asked about the initialization of I, but also progression on I's input. Because if you don't progress on I, you will have an infinite while loop. Does this make sense? So if you have a condition that really depends on variables, check your values. Are they really initialized correctly? And also are they progressing in a way that they are changing? Because if the condition evaluates true, but nothing of the variables changes over execution of the loop, it will remain true forever. This will be an endless loop. Accept? Any other question? Okay, so we said this is a valid for loop in C. Basically, I don't have any expression here, and I don't have any expression here. What about do while? Well, do while is a little bit different. So there are use cases where, in fact, you want to execute the loop at least one time before checking the condition. For example, we have wrote a program, if you remember. Do you remember the program where we said we want to keep reading from the user numbers until the user inputs 1, and this will be my termination condition, right? So we wrote this program in maybe the third or the fourth lecture, and we wrote it using while loop. The problem is, if you recall, we needed, in fact, to repeat the statements of the loop one time before the loop at least to read from the user. So we asked the user, please insert an integer value and insert 1 to terminate, and then we read one value, and then we use this value inside the while loop condition to check whether it's 1 or not. And if it's not 1, then I repeat exactly the same thing. Please insert something and then I scan it. Why did I need to do this in a while loop? Because I wanted to execute the reading from the user at least once to have something to check against 1, right? This is the typical use case of a do while. If I had a do while, in fact, I wouldn't need to repeat this code before the loop. I can just have it inside the do while loop. And in this case, the only difference in the do while is, if you look into the flowchart, I execute the statements once before checking the condition. In the while loop, this condition before the statement. So if the condition is false, it will never evaluate. The statements will never execute. But in the do while, statements are executed at least once, even if the condition is false from the beginning. Good? So if you think here, if I want to transform this number into a do this code snippet into a do while, then again I will initialize I. Well, here I'm checking my condition directly. But in the do while, I'm really running it first and then having my condition. Right? So it's just completely equivalent in that case. But let's have a special case of n to see really whether they are completely equivalent or not. What if n is 0? What do you think? In other words, are these two programs completely equivalent in all cases? Well, they are completely equivalent except if the condition is not true even at the first time. Because if n is 0, I come here into the while. 1 is less than or equal to 0 is false. I will never break anything. So this program will end up not breaking anything in the console. But here, if n is 0, well, I end executing of this at least once. So I'm going to get really 1, so I'm printing I, And then incrementing I coming here, well, I will be 2, but n is 0, so I will never execute again. So you end up having one printed on the console. You see that? So basically, the main difference between the do while and the while that you have to pay attention to is the corner case, which is the very first time you check your condition. Do while will always execute, regardless of the first condition whether it's true or false. While in the while case, it might not execute at all, based on whether the condition is true or false. Afterwards, after this first time, well, they behave exactly the same way. Good?